Have you ever pondered about the celestial dance of the sun and its magnetic field? Our radiant sun, the heart of our solar system, is engaged in a cosmic ballet, a dance with an 11-year rhythm known as the solar cycle. This cycle is a magnetic pulse, a heartbeat that influences not just the sun but our lives here on Earth as well. At the core of this cycle is the sun's magnetic field. Like a cosmic dynamo, this field flips polarity, with north becoming south and south-north. This flip, this pulsing rhythm, births the solar cycle, a phenomenon as enigmatic as it is influential. This celestial dance has far-reaching effects, influencing our planet's climate and even our technology. From the vibrancy of the northern lights to the functioning of our satellites, the solar cycle shapes our world in ways both subtle and profound. Dive in as we unravel the mystery of the solar cycle. The solar cycle, in essence, is the sun's heartbeat, a fascinating rhythm pulsating through space. It's a cycle that lasts approximately 11 years, during which the sun's magnetic field undergoes a full transformation. But what does this mean? Let's break it down. Imagine the sun as a colossal magnet, just like the small ones we use here on Earth, but with a twist. Every 11 years or so, the sun's magnetic poles flip. North becomes south and south becomes north. This is not a sudden flip, but rather a gradual shift, a magnetic dance that takes place over the span of a decade. Now, this dance is not a silent one. It produces what we call sunspots, areas on the sun's surface that are cooler and less active than their surroundings. These sunspots appear to wax and wane in number over the cycle, reaching a peak known as the solar maximum and then dwindling to the solar minimum when the sun is most serene. But the sun's dance is not just about sunspots. There's more drama involved. As the magnetic field lines get twisted and tangled during the flip, they can suddenly snap and release a tremendous amount of energy. This results in spectacular solar flares, which are like the sun's fireworks, and coronal mass ejections, massive bursts of solar wind and magnetic fields ejected into space. These solar winds, a stream of charged particles flowing outwards from the sun, are not just a space weather phenomenon. They reach all the way to Earth, causing beautiful auroras, but also potentially disrupting our satellites and power grids. In a nutshell, the solar cycle is a complex and beautiful dance of magnetic fields, sunspots, solar flares, and solar winds. It's a cosmic rhythm that the sun has been following for billions of years, and will continue to do so for billions more. So the solar cycle is a cosmic waltz that impacts us more than we realize. But how does this celestial ballet affect us, you ask? Well, let's dive right in. The solar cycle, this cosmic dance of magnetic fields, has profound effects on our planet. The most noticeable of these effects are solar flares. These are sudden, intense flashes of brightness caused by energy released from the sun's surface. When these flares reach Earth, they can significantly disrupt our communication and navigation systems. Imagine this. You're on a call with your best friend sharing the latest gossip, and suddenly, the line goes dead. Or perhaps you're navigating through a dense forest, relying on your GPS, but it inexplicably fails. Such scenarios could be the result of a powerful solar flare interfering with our technology. The solar cycle also influences our climate patterns. During periods of high solar activity, the Earth receives slightly more solar energy. This can subtly affect weather systems, contributing to climate variability. However, it's important to note that these changes are minor compared to the more prominent human-induced climate change. So, while the sun does play its part, it's not the main actor in the climate drama, but it's not all doom and gloom. The solar cycle also brings us one of nature's most spectacular displays, the auroras. These ethereal light shows, also known as northern and southern lights, are a direct result of solar particles colliding with Earth's magnetic field. During periods of high solar activity, these displays become more vibrant and can be seen from higher latitudes. It's a cosmic light show right on our doorstep. Understanding the solar cycle is crucial as it allows us to better prepare for these impacts. Scientists are continually studying the sun, trying to predict its cycles more accurately. With this knowledge, we can safeguard our technology, plan for climate variations, and even predict the best times to view the auroras. Indeed, the sun's rhythm shapes our world in more ways than one. Yet, the solar cycle holds many secrets yet to be discovered. Like a cosmic puzzle, its pieces scattered across the vast expanse of our universe, waiting to be pieced together. The enigma of the solar cycle continues to baffle scientists and astronomers alike. It's a tantalizing mystery, one that we are still trying to crack. You see, the solar cycle isn't as predictable as we'd like it to be. It doesn't adhere to a strict 11-year cycle as one might think. Sometimes it can be as short as 9 years or stretch up to 14 years. The intensity of the cycle isn't consistent either. Some cycles are remarkably tranquil with fewer sunspots, while others are tumultuous, bursting with solar flares and coronal mass ejections. These inconsistencies, these variations, are what make the solar cycle so intriguing. They're clues, breadcrumbs that lead us further down the rabbit hole. And scientists are following these crumbs, conducting research, running simulations, and collecting data to better understand this celestial phenomenon. But why is this so important? Why do we need to understand the solar cycle? Well, it's simple. The sun is our closest star. Its behavior directly affects us. Solar flares can disrupt our communication systems. Coronal mass ejections can cause spectacular auroras. Understanding the solar cycle allows us to predict these events, to prepare for them, and to mitigate their effects. However, we're still at the beginning of this journey. Despite the advances we've made, there's still so much we don't know. We're still learning how to predict the length and intensity of each cycle. We're still trying to understand why some cycles are more active than others. We're still unraveling the complex interplay between the sun's magnetic fields, its plasma currents, and the solar cycle. As we delve deeper into this mystery, we're not just learning about the sun, we're learning about the universe, about its laws, its rhythms, its patterns. We're learning about ourselves and our place within this vast cosmic tapestry. As we continue to unravel the sun's secrets, we realize that our journey with the solar cycle is far from over.